Okay, last day for section 2.1. We're going to wrap it up by talking about max and min values and how they apply to application problems. And we'll also kind of do one more example of sketching a graph on example 3. Okay, so let's start there with example 3. I want you to swap it out for this one. All right, f of x equals negative 2x squared plus 2x minus 3. Go ahead and write that in. Okay, remember the directions are on the previous page. So it says write the quad function in vertex form. We're gonna skip that when a is not 1. When it is 1, we went through it in examples 1 and 2. Move the c term over. You worked on it on a few problems yesterday. Okay, but if a is something other than 1, I'm going to allow you to skip that because we're not going to go over it this year. Okay, so might want to just make note of this. When a is not 1, just find the vertex using Tuesday's method that we went over. Opposite of b over 2a. Then once you get it, plug it in the function. Okay. On your next quiz, I'll probably have that up on the board or on your quiz, and then the quad formula. Okay, so if you're worried about memorizing those, I'll have that ready for you. Okay. All right. So, and if you just want to reiterate that, or if you get it from me already telling you, I'm going to allow you to skip the step of putting this into vertex form under this scenario. Okay, when a is not 1. Okay, so with that in mind, we got all the skills now. I want to give you guys 2 or 3 minutes to work on this. I want you to go find the vertex using this method, and then start finding the x-intercepts and y-intercepts. Those 3 things: x-intercepts, y-intercepts, and vertex. I'll be around to help if you need some. Go ahead and pause now. Okay, here's your x value for your vertex, opposite of b over 2a. So we get positive 1/2. Take that positive 1/2, throw it into the function to see what you get, and it gives me negative 2.5. So there is our vertex. Okay. And if you start getting the graph going, we're over at 1/2, down at negative 2.5. Can actually start drawing some conclusions on what's going to happen on our x-intercepts, especially since I have a y-intercept of 0, negative 3. So that's here. Since my a value is negative, whenever that's negative, it's supposed to open down. So my parabola is starting to look like this. How in the world am I going to have any x-intercepts? Okay, if you recognize that ahead of time, great. You could say opens downwards and vertex is below the x-axis. Not going to happen. All right, but here's the work that you guys were starting. I've always told you to try to make a positive. It hasn't happened a lot, but when it does, making it positive makes it easier to factor and through the quad formula. Okay, not that you can't do it, but I just recommend it, okay? All right, so I just multiplied everything by negative 1 to get to this step, both sides. Okay, so I can't factor it. So x equals the opposite of b, so positive 2 plus or minus the square root of b squared minus 4 times a times c. Okay, so here we have 4 minus 24, right? Yep. So that gives me negative 20 over 4. Okay, so as soon as you get to a scenario where you have a negative under the radical, we're not going to get a real solution. So you can stop here. We'll say there's no x-intercepts. So when you get to the point where there's no solution, so then you'll say, therefore, there's no x-intercepts. That's what we were seeking out to find. So no solution means no x-intercepts, okay? All right, so really the only thing I really need you to do here to complete the graph is just maybe just reflect this. Remember, we got a line of symmetry going right here through x equals 1/2. Well, the reflection point of that y-intercept then will just be 1/2 unit away, so it's going to be over here. Okay, and if you want to punch in your calculator and get some other solution points, fine, but for now, this would be enough if you don't have the x-intercepts. Okay. Okay, example 9 on the next page. We've kind of used parts of this box already, but we're really going to use it even more here with the applications. All right, so minimum and maximum values, whenever the A value is positive, we talked about this yesterday in class in the warm-up. At home, you guys didn't have this discussion, so let's discuss it again real quick. If I just have a real basic function like y equals x squared, A is positive. So every time, the parabola will open upwards and therefore have a minimum y value. If A is negative, so another real basic one, like y equals negative x squared, now it flips it downwards. And naturally, the parabola will have a maximum y value, okay? All right, so let's go ahead and take a look at number 9. Go ahead and take a moment to read that setting. Okay, they're giving us a quadratic function to represent the situation. It's not required, but why don't you do that for this example? I think this would be good to give you a little visual aid of what's going on. Okay, why don't you just draw big first quadrant over here. F of x, or y, is the height of the baseball. So we have height over here, and then x is the horizontal distance. So we've got horizontal distance. And it should make sense why we're in the first quadrant, right? We have positive values going on, positive x and positive y. All right, we just talked about what happens when you have a negative a value. Negative a value, it opens downwards, and that makes sense. So our parabola is kind of looking something like this. Doesn't have to be perfect, just kind of want you to put upside down parabola in the first quadrant. Okay, so first part, we're actually going to do 3 parts to this question. I want you to label this as part A. What is the max height of the baseball? That's part A. What is the max height of the baseball? Well, you got to realize that they're talking about the vertex of the parabola. So we got to find this. How do we find that? Right here. Okay, they're just messier numbers and decimals. We just got to deal with it. Okay, so part A, let's answer it right over here. X equals the opposite of B over 2A. So my B value is 1, right? So negative 1 over 2 times A. Negative 0.0032. Okay, punching this in the calculator. Maybe you want to try it just to make sure you know how to do it right. Negative 1 divided by, but not just one thing. I need to divide it by a product. So you have to put parentheses right here. 2 times negative 0.0032. It's got to be expressed like that. And we'll get our x value. Okay, 156.25 is x. All right, now that we have x, how do we find y? We plug it into the function. So I'll just put a slash mark here to separate this process. So I keep moving this way. So the function evaluated with 156.25 is, and we know how to do this, just plug it in here, plug it in there, let the calculator do the work. I already have the answer for you. It works out to be 81.125. Okay, so here's our vertex, right? Our vertex is at this x value and this y value. Pause for a moment, let you write that down. All right, now the trick to the end of this is what is the max height of the baseball? We got to figure out which of these values is the max height. So that's why I think this visual aid up here is key. Or just go back through and realize that f of x, y, is the height. So it's 81.25. Maybe that's enough for you. Or you go back over here and take a look. This is the y value, right? This is the height. So 81.125. So max height, here's the answer. Max height is 81.125 feet. Okay, I want you to add this for part B. How high is the ball when it was hit? How high is the ball when it was hit? Okay, two ways you could think about this. This is the moment of impact, right? Exactly when that ball was hit means it's the y-intercept. So the graph might help you realize that, or you just think about how far has it traveled along the x-axis. At the moment it's being hit, the x value has to be 0. It hasn't traveled anywhere. So we need to let x equal 0 under this scenario. So we need to let x equal 0. Hasn't traveled yet. If you want to write that in there, go ahead. Okay, so f of 0 is, this is one of the easiest calculations, because we're just going to get 3. So 3 feet high is how high the ball is when it was hit. Add to that it's the y-intercept if you want. That's what we just found. Okay, last part of this. Probably the messiest part too. Go ahead and write this down for part C. I'll pause it while you're writing it down. How far did the ball travel horizontally? All right, what we have to realize here is how far did it travel? That means the ball hit the ground. It has a height of 0. Okay, it's the x-intercept. Okay, so how far the ball traveled horizontally? This is when the ball hit the ground or has a height of 0. I'm going to say it has a height of 0. Has a height of 0. So that means y equals 0. Or you could add it's the x-intercept. Whatever clicks with your brain here, we need to realize we need to find the x-intercept or set y equals 0. Okay? So 0 equals this equation. Okay? This is why we have multiple methods for quadratics. Have fun factoring that. No thank you. Have fun doing the square root method. Can't do it. Okay? Quad formula was meant for situations like this that are a little bit tougher to deal with and tougher to factor. So we get x equals opposite of b, so -1 plus or minus b squared minus 4 times a times c, all over 2a. Okay, let me help you with the calculations here. I would start under the radical every time. Let the calculator do the work. I don't care if it's messy or not. If they're clean numbers or messy numbers, you do the same thing. So b squared minus 4 times a times c. So I get 1.0384. So this gives me -1 plus or minus the square root 1.0384 all over 2 times that number. So -0.0064. All right, so as we talked about before, getting these decimal answers, close the numerator, plug it in. We get this, hit second enter, and you can type over and hit minus. Here's my 2 answers. This one's we're going to throw out. -2.97 is over here, but the one over here, the positive one, makes sense, and that's going to be our answer, the 315.47 seconds. So throw out the negative, keep the one that makes sense. There's our answer.